This is your reality check.
Hi everyone, and welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. This is your show for August 30th, 2016, and I'm your host, Darren McKee. With me, as usual, are Adam Gardner.
What's up, Cuboids?
Christina Roach.
Hello.
And producer Pat.
Hi, everybody.
But we also have special guest Stuart Robbins.
Great to be here.
Great to have you. Stuart is happily going to give us an update on various things astronomical, including Proxima b, the recently discovered, perhaps, exoplanet. And Adam is going to look into whether Scrooge McDuck could swim in his money bin.
Indeed.
But first, helium-infused beer. Is this actually a thing, Pat?
So I wanted to cover this really briefly because it popped up in my Facebook feed a few times in the last week. It's a video of the two guys from the German language podcast, Dear Beer Pro Beer, tasting a limited edition helium-infused beer called Helium, spelled Y-U-M, from the Samuel Adams Brewery in Boston. So I'm sure everyone is familiar with the effect inhaling helium from a balloon has on someone's voice. And when these guys taste the beer, it has essentially the same side effect. And it's pretty funny. The video has 3.5 million views and was originally released in April 2015. Have any of you guys seen this?
I've never seen it.
I saw actually without the sound, one of my feeds, I didn't have time to click on it.
I think the sound would probably be crucial.
I think so.
Right. So it turns out there are several videos like this, including one from the Samuel Adams Brewery themselves announcing the Helium product. It was released a year earlier in April 2014. There's also a video from a brewery called Stone Brewing in California announcing a similar product released in April 2014, and one from the Berkshire Brewing Company announcing a Helium IPA, which was published to YouTube on March 31st, 2015.
Oh, what interesting dates, Pat.
So I'm sure that you've probably all picked up on the idea that each of these videos was released on or around April Fool's Day, and it's a pretty good gag. That said, lots of people thought that the German podcaster's video in particular was real. Andy Sparhawk from craftbeer.com says the site started getting questions like, am I able to buy this and get it sent to Australia? And really want to try this. Any retailers in Scotland? Maybe sadly, though, you shouldn't hold your breath for helium beer. So here comes the science. Rick Blakemere from Stone Brewery gave the following explanation as to why helium beer could never exist. Helium is not soluble in water, or beer in this case. You can't carbonate beer with helium like you can with carbon dioxide or nitrogen. Adding liquid helium wouldn't work because of its extreme low temperatures. You'd freeze the beer. Even if you could somehow add helium to beer, it would come gushing out when you open the container. It would make a mess, and you wouldn't get it anywhere near your mouth to drink it. Blake Meyer, who is featured in the April Fool's video by Stone Brewing, says, quote, who knew that this would capture everyone's imagination? I guess I could make a fortune if I could somehow violate the laws of thermodynamics and physical chemistry and put helium in beer. So when I posted to one friend's Facebook page that it was actually a joke, she told me she still loves me, but that I ruin everything.
Isn't that our motto on the show?
Yeah.
Right.
Okay, I have an idea.
I have one too. Let's hear what yours is.
So you fill the bottle like with beer normally, and you have like a super cooled cap with the helium like in a mesh as a solid in the cap. And then you put it on in a highly compressed environment so that the pressure of the beer will make the helium remain in a solid state, but not only remain in a solid state, but remain at the top, because I think the problem was if you put it in, it would splash everything up in your face. So then when you open the beer, it heats up, while the pressure goes down, then the helium goes out of the beer, and then as long as you inhale it right at the right time, theory, maybe that'll work. So maybe someone can tell me why that's nonsense, but that would be my closest idea to how something like this might be able to be feasible.
So my idea was you get a medium-sized balloon, you
Yep.
fill it with helium, then a certain amount of beer, so it floats at about head level It has a valve, and you can just drink the beer on the bottom and then also suck in some helium at the same time.
It's not bad.
Because drinking and taking in air is wise.
Well, so this friend asked me how the video was actually accomplished. And the answer is very likely that they used an audio plugin to alter the original audio. Apple's GarageBand, for example, even has a preset called Helium Breath.
Pat, to demonstrate this, could you talk in a high-pitched voice right now? I could probably do that in post.
Thank you.
Anyway, so there you have it, guys. Helium beer? Yeah, it doesn't exist.
I would also just add that helium is a non-renewable, very limited resource. So using it for something like this when it has so many medical applications is actually not a good idea.
Even if you could do it, it would be preposterous to do it. I did read that as well, Stuart. It's a good point.
Okay, Stuart, what if the helium-infused beer was so popular, yet used such a small amount of helium that it encouraged people to seek out new helium resources in nature, such that more was available for cheaper for the medical applications because of the beer?
In nature, Adam, or on exoplanets?
Well, oh yeah, that too.
Stuart's here to talk to us about Proxima b. He's a research scientist who studies planetary geophysics. He's also the host of the Exposing Pseudo-Astronomy blog and podcast, which you can find at podcast.sjrdesign.net. But before Proxima b, Stuart, can you give us an update on New Horizons?
Sure. So the quick notes are over 90% of the data have been downlinked from the encounter last year. It has been awarded an extended mission to go to what we are now calling MU69, or 2014 MU69. It does not have a better pet name yet. That funding goes through fiscal year 2021 to 2022 at the moment. So the U.S., the fiscal year starts over every year on October 1st. I am involved in the extended mission, so that's kind of cool, especially with the planning part. And science-wise, lots of science papers have been written. There have been over 20 for a special issue of one of the main planetary science journals called Icarus, including mine. My paper happens to be a little over 18,000 words and just got back from its second review. So It takes a while.
Stuart, this new object, it's just a Kuiper Belt object, essentially?
Yes, so it's roughly about 40 kilometers across. So New Horizons won't actually resolve it until it's maybe a month or so away.
And this was chosen just because they could get to it, or because it's interesting for some special reason, or?
Yes.
What's the special reason that it's interesting?
It's another Kuiper Belt object, and it's an object in a size that we've never really visited before either.
Cool. Interesting.
Great, Stuart. That's very exciting. Now, what about this exoplanet that was been in the news lately?
Yeah, so this has been exciting. It got a lot of press the day before it came out. That has to do with just the way science journals kind of work these days. So there were rumors floating around that some kind of exoplanet had been discovered nearby, and people immediately started saying, well, the reason it hasn't been publicly announced is because there are aliens there. No, it's because the journals are old-fashioned and they like embargoes. So it's like, the paper's been accepted to a journal, and the journal is going to have a big press conference on a certain day, then everyone's going to be involved, and no one can say anything beforehand. And if they do, then that journal is never going to let you publish with them again, and blah, blah, blah. It gets really to be a major pain in the ass. But
so who gets to read those journal entries before it's officially released?
So usually what the professional science journals will do is they'll say there's going to be something, a press conference of some sort on this day.
Okay.
And they have already accredited reporters who will get special early access to the paper upon signing a non-disclosure agreement.
Okay.
And so that's how you get your hand in there. All right, so the basics of this star, first off, is it's Proxima Centauri. You may know that the first word Proxima means sort of nearby. It is the closest known full-fledged star to our solar system. It's about 4.25 light years away. It's actually part of a triple star system, along with Alpha Centauri A and Alpha Centauri B. But Proxima Centauri is a really small star. It's only about 12% the mass of the sun. It emits only 0.15% the luminosity of the sun, so the brightness, and it's only about 3,000 kelvins in temperature, which means that it's very red. So it's a red dwarf star. That also means that it could last for hundreds of billions, if not trillions of years, because it goes through its nuclear fuel so slowly.
Wow.
So the planet that was discovered orbits Proxima Centauri in about 11.2 days, and you can use Kepler's laws to give you the distance, so it's about 7 million kilometers, or about 4.4 million miles for the U.S. audience, from the parent star, which is only about 5% of an astronomical unit, and an astronomical unit is the distance between Earth and the Sun. So this means that it's also about 6 times closer to its star than Mercury is to our Sun.
Wow.
Now, you might be thinking that's ridiculously close and it's going to burn up. But because the star itself is so faint, it actually means that it's in the habitable zone. And the habitable zone here only means that the temperature at the distance of the planet is warm enough and yet not so warm that liquid water could exist on the surface. That's the only criteria in this case. And the body itself is probably about 1.3 times the mass of Earth. So it would probably be a rocky terrestrial type object.
So, Stuart, is that just a mathematical equation to say, okay, well, it's got this luminosity, it's putting off this much heat, it's this distance, therefore could support water?
Yeah, so it's actually a very simple equation. And I wish I remember what it was called. It might be something like the thermal equilibrium equation or something. But basically, the star's light goes out in a sphere, and so the distance from the object squared is a way to scale the temperature of a body at any given distance from the star, and then you multiply by things like luminosity and 4 and pi and a Stefan Boltzmann constant. But it's actually a very straightforward equation with like a square root and maybe a power of 2 or a square or somewhere in there. So the distance from its star, it's very close by. This also means that it is probably, even though it is in the habitable zone, not probably well suited for life. And the reason is that it's probably tidally locked. And tidal locking means that it's like Earth and the Moon. It always shows the same side towards the star. If it's not tidally locked, then it might be in a 3-2 resonance. That is sort of like Mercury is to our sun. So every time Mercury goes around our sun twice, it spins on its axis 3 times. So that's another kind of locking that it could be in. That would also be difficult for life to survive or even form on that kind of situation, unless it may be formed underground, perhaps. But, you know, anything is possible. When you start to speculate about life, I really don't like to, just because we have what we call in science N of 1. In other words, we have one example of where life is. And so any kind of extrapolation in these games that the astrobiologists like to play is really, really hard to know what's real and what's just wishful thinking.
Stuart, if a planet is tidally locked, is it possible in the past it wasn't?
Yes. However, I am not a dynamicist, so I say yes with caution that it's possible that if it formed so close to its star, it could have formed in a tidally locked situation, or it could have developed over the course of time.
Interesting. I think I will now answer all future questions with, I'm not a dynamicist, but let me tell you what I think.
Yeah.
Now, if it is tidally locked, isn't there sort of a ring between the light side and the dark side that would potentially be habitable or close to?
Yes, that is also a possibility. But if there's an atmosphere, then you could get extreme winds right at that edge, which could hinder the development or stability of life. But besides tidal locking, you also have a lot of radiation that close to the star. Even though it's pretty faint, you're really, really close.
Well, do we have a way to tell whether or not there's an atmosphere at this point?
No. So that gets to follow-up observations that the team who discovered this are trying to make, is to determine whether or not the planet passes in front of the star as seen from Earth. There's a very low chance that that's actually the case, but if it does, then we would be able to use other instruments in order to detect an atmosphere. So like the very beginning and very, very ending of when the planet passes in front of the star versus going away from the star's disk, you would effectively see the star's light filtered through the planet's atmosphere. And so we could start to learn whether it has an atmosphere, and if so, what kind of atmosphere it may have.
So, Stuart, are the current ground or space-based telescopes we use, are they sensitive enough to investigate this further, or do we need something new to help verify this?
Well, so this was actually made with a ground-based telescope system. So the reason why it hadn't been discovered earlier was that the instruments were not sensitive enough at the time. So there were hints of the object around the year 2000, but the noise level versus the signal was just too high. So the team basically wanted to do follow-up observations, and they got a lot of telescope time. They used the European Southern Observatory's telescopes and spectrometers in Chile. They got 20 minutes every night for a little over 2 months, and getting that kind of telescope time is ridiculously difficult to do.
Wow. That's very cool.
Yeah, so they were able to use the latest and greatest equipment and basically improve on the 2000 study with the very sensitive equipment and pick out by what we call the radial velocity method this little planet around the star. So the radial velocity is where as the planet and star orbit around a common center of mass or common gravitational center, as the star goes towards us and the planet goes away from us, the star's light will be blue shifted. It'll be shortened a little bit. And then as the planet comes towards us and the star goes away from us, it'll be red shifted a little bit or lengthened. And so that's how this was discovered. So as equipment improves, I would suspect that these basic kinds of observations of its period, its distance, etc., will be known to better precision. But as to whether we can do anything further, like whether there's an atmosphere, unless the sucker passes in front of its parent star, I don't think we'll be able to do much of anything.
So does this method suggest or tell us that this is either the only planet around that star or the most sort of significantly sized planet around that star?
There might be another planet around the star. There were some hints at a signal at about 100 days and 400 days, but that would be a lot of telescope time because basically you need to observe it for at least twice that period. So we would have to have a baseline of observations that spans 800 days, which is over 2 years, and the farther you are from the star, the weaker that signal is going to be. So even Jupiter pulls on our sun with a little bit of a signal, but if Jupiter were at the position of Earth, its signal on the sun, its little wobble that it causes as they go around a common center of gravity, would be something like 25 times bigger. So,
oh, wow.
Yeah, so there might be a signal, and that is something that could be done with further ground-based observations, but that would require a lot of dedicated telescope time.
It's great to have an expert to talk to us about this stuff, Stuart, but before we let you go on this topic, it'd be remiss to not ask you about a recent signal, which is labeled as a possible SETI candidate, that supposedly was detected in Russia over a year ago, but they just released it now. Do you have any thoughts on that?
Yeah. How blunt can I be?
As blunt as you'd like to.
It's stupid. I mean, when I first read the first story, I was like, oh, this is kind of cool. And then I read more about it, and I'm like, this is really stupid. So basically, there was a strong signal detected from a star on May 15th last year, and they basically, the telescope that was used to detect this is so complicated that they don't know if it was a narrowband signal, which is something like at a very specific frequency and would be indicative of life, or a wideband signal. They don't know if it was a passing airplane that might have flown in. They don't really know much of anything. And they didn't follow proper procedures, which is sort of to alert the astronomical community that studies this kind of thing in order to do follow-up observations as soon as possible so that they can see if something is there. Like, for example, if you can imagine Earth is going to send out a big, giant signal, it's more likely we're going to send it out over the course of a few days than have a steady, whopping signal for over a year. So it's kind of silly. They didn't follow the right protocols, and now SETI is doing follow-up observations, and they're basically seeing absolutely nothing. So they looked at where the Russians said was the frequency of light or radio emission that they thought they saw the signal in. They saw nothing. Now they're widening the band. They see nothing. But basically, the more this story is playing out, the more people are grossly criticizing the original detection and saying this is pretty bogus.
There could be fabulous riches on other worlds, like unobtainium or something like that. Maybe Scrooge McDuck from DuckTales got rich back in the day and we don't know about it. He had that big bin that was full of money and he used to swim through it all the time. Adam, did that make sense that a duck would swim through money?
I have a change basket at work. I put my loose change in there, which in Canada includes $1 and $2 coins, so it adds up. Well, I put my hand in it the other day, and it was kind of hard to move my fingers around. It was hard to sort of push into the coins, and this got me thinking about cartoons, which is something I do often. So DuckTales and other stories feature Scrooge McDuck, a cartoon duck with enormous riches, who has a money bin in which he swims around in all his money. Mostly filled with coins, but there's also like bills in there, those rolls of bills that you like to see in cartoons, and these bags with dollar signs on them, which are filled with either coins or actual bills. So mostly coins, but he swims around in this stuff. The money bin has been around for years, first appearing in Uncle Scrooge comic stories, but then made a few animated appearances and eventually showed up in the animated series DuckTales that we all know and love. And Scrooge will, as Darren said, frequently swim in his coins. Is this possible? Some fans have speculated about how this might make sense. Maybe the coins are transformed in such a way to make them ultra slick that allows him to swim in it, similar to how you would swim in a ball pool.
Oh, man.
This wouldn't really change the weight they'd put on him, so that might not be a great idea. One person suggested that they be aerated from below. Not exactly sure how that works. A normal human would simply not be able to swim in all those coins. Even in the fake world, which Scrooge McDuck lives in, the city is Duckburg, but the universe of Scrooge McDuck and DuckTales doesn't really allow for a normal person to do it. When the Beagle Boys try to swim in his money bin, they aren't able to. But then, aren't ducks better swimmers than dogs? So Scrooge McDuck seems to be the only one who can swim in his money pit. And one comic mentions that years of bathing and burrowing in his money have taught him to swim in it, a skill which he can only use in cash, somehow. So that obviously doesn't make a ton of real-world sense. Swimming in liquid is one thing, but you can't really swim in solid objects like that. Coins are too heavy, they're packed together too tightly, they don't move like water. You can't really move something that's packed that tightly. If you could move something that was packed loosely enough, then you would sink. We're mostly made of water. We float in water. Floating in coins isn't really going to work that well. If you manage to get under some of these coins without sinking, the weight would probably crush you. If you manage to get under some without sinking or getting crushed, you might suffocate while trying to get up for air because you'd be moving so slowly. Some things work a bit more like this than coins, like the ball area at IKEA. But these are sort of larger and lighter than coins, and it's not like these are feet deep. A child could still stand in this area if it wasn't filled with balls. So it doesn't really compare. But really, it's a cartoon. It's just because it's a cartoon. Scrooge seems to have other money-related superpowers. He can recall how he got every single coin or piece of, piece of money in his collection. He can smell money. He seems to have a psychic connection. If someone's taking his money, he gets a feeling about it. It's a cartoon.
My money sense is tingling.
Yeah, I mean, they're ducks, right? They go to space. They have genies in this thing. Now, when the DuckTales game for the NES was remade a few years ago, a prop money bin was made, and people could sort of pose in it and cover themselves in money, and that was all cool. But these coins were really massive pillows, so larger, lighter in density than real coins, not really the same. Little side fact, Scrooge McDuck's money bin is ridiculously large, so much so that all of the gold in the real world wouldn't fill it up. Now, the fine people at Observation Deck crunched some numbers. The bin is said to be 3 cubic acres, which doesn't make much sense, because an acre is a measurement of area. We can imagine that this means a cube with an acre on each side. There is, however, a comic from 2001 which shows blueprints of Scrooge's money bin, and from this we can calculate that it is a bin that is 115.7 feet by 85.5 feet. It has about 90 to 95 feet of actual money in
That's
depth.
when you know you're rich. How rich are you? Like 80 feet? 80 feet of money, rich.
Yeah, that's pretty rich. So he's just like the richest man in his universe. So we have 171,300 metric tons of gold in the world, measured as of 2013. So that would be a cube of 68 feet on each side. That's 20.7 meters on each side. Easily fits in the bin. Even if you account for sort of the air that would be in coins, if it is in coin shape, it would only fill about 57 feet of the bin, which is actually close to filling the bin, but not quite. Of course, there's enough silver to overflow it, and there are more than enough bills in U.S. currency in circulation to fill it. And the article also estimated the number of U.S. coins in circulation, considerably more than we need to fit in the bin. So it's never really stated that it's only gold coins in this bin, although when you look at it, it mostly seems to shimmer in gold. But there's cash and there's bags. So if there's a little bit of silver mixed in there, the richest man in the world could fill this bin. Scrooge McDuck is a fictional character with a great deal of money, which might fit in his ludicrously large money bin if it wasn't all gold, and his ability to swim in this money seems to be as unrealistic as the concept of a bunch of pantless, intelligent, humanoid ducks.
Thanks, Adam. You nailed it once again, giving us an inane topic with a kernel of wisdom about just how much the gold there is in the world, and it's smaller than I thought.
Darren, just before you wrap up, I want to ask Stuart. Stuart, what's going on with pseudoastronomy?
I intend to relaunch it before the time this podcast goes out. It should be relaunched with a Flat Earth episode, and I've been taking a lot of notes on what a lot of idiots have been saying. So that depends, of course, if I retain my voice, because I might have come down with strep throat, and if I go hoarse, then I won't be able to record. So it might be delayed.
Awesome. Looking forward to it, Stuart.
Me too.
And thank you for joining us once again. Tonight we covered that Helium infused beer, although it sounds awesome, it's not actually a thing, unfortunately. We thank Stuart for joining us once again, who gave us a fantastic overview of the recent finding of Proxima b and what that may entail. It's basically in the habitable zone, but that doesn't necessarily mean there's life. It's complicated. And Adam explored whether Scrooge McDuck can swim in his money bin. And it turns out, not bloody likely. Until next time, think better to act better.
Peace out, cuboids.
Stay classy, not smartassy.
To paraphrase a former TRC host, be skeptical, don't give in to susceptible.
Thanks for being here, Stuart.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at TRC_podcast.
Outtakes.
My memory is flawless, and so therefore these things are different, and it must be I'm switching realities. I'm switching realities every day.
It's because I have a quantum computer for a brain, obviously. Come on.
To be fair, those people aren't dynamicists either.
No, they're idiots. I sense Pat's pulling outtakes.